This video is a brief introduction to magnetic force. So this is a magnetic field pointing in the positive x direction, and these are two positive charges that are now within the magnetic field. These two charges have two different velocities. One charge is traveling perpendicular to the magnetic field, and the other is traveling parallel to the magnetic field. The charge that moves perpendicular to the magnetic field feels the maximum amount of force, and the charge that moves parallel to the magnetic field feels no force at all. This is a very important thing to remember. Charges must have a velocity in order to feel a force. This means that if a charge is placed at rest in a magnetic field, it will remain at rest because it will not feel any force. Charges that move parallel or anti-parallel to the magnetic field will not feel any force at all either. The maximum amount of force is felt if the charge is moving perpendicular to the magnetic field. So you may be wondering when the charge feels a force less than the maximum but still larger than zero. And the answer is when the velocity is at an angle to the magnetic field. The equation for magnetic force is the charge multiplied by the velocity of the charge and the strength of the magnetic field. So let's do an example. An electron moving in a magnetic field of strength 0.35 teslas experiences a force of 5.2 times 10 to the negative 15 newtons. And we want to calculate the speed of the electron. So we're going to use our force equation that we saw before. We know that the force is 5.2 times 10 to the negative 15th. The charge is an electron, which is 1.6 times 10 to the negative 19th coulombs. And we knew that the strength of the magnetic field is 0.35 teslas. And when we do the math, we see that the velocity is 9.29 times 10 to the 4th meters per second.